and they're going to talk to us about how PTC has developed in America and also make some comparisons with the European train control system and the European traffic management system. So, Joe, you want to go first?
Carl, thank you. Oh, ow. That'll wake you up. Well, thanks so much for sticking around. I know some of you are here just for the drawing, so I'm going to try to be as brief as I possibly can. They gave me, of course, the easiest and most and least controversial subject to speak about today to end up the conference, which is positive train control. We do have some good news for you, though, which is that there has been a similarly difficult time getting this stuff done in the UK. We're going to tell you a little bit about that story. So the first thing I want to do is just kind of introduce you a little bit to Network Rail. A lot of you probably know Network Rail as the national owner-operator of the UK rail system. It's kind of unique in that there's a single company that owns, operates, maintains the entire infrastructure, owns 2,500 stations. I think I have some statistics, so let me just move forward. We are Europe's #1 railroad at this point, according to the European Commission. We're the safest, we're the fastest growing, and we are the most improved railway, which I'm not exactly sure what that means, but I remember getting a most improved trophy when I played football, and it wasn't really something to be proud of, I don't think, because I was terrible, and I was a little less terrible the next year. So our operations in the UK are pretty impressive. We carry over 4 million passengers per day. 20,000 train movements are managed by our train dispatchers, and we do incident response across the entire network in addition to maintaining it and improving it. You can see the miles of track, signals. The interesting thing for me, and I'm fairly new to the company, but one of the things that really kind of caught my eye was in the transition from Railtrack. If you know the story of Railtrack, which was kind of an abortive attempt in the UK to have a private company own and maintain the infrastructure, which wound up turning out not so good and actually led to the creation of Network Rail. We've been able to achieve a 40% reduction in the cost of running the railroad over the last 10 years, which is pretty darn impressive. We also own 2,500 stations across the country, and we operate the 18 largest and most iconic, especially those in the big cities. I'm not going to do death by PowerPoint and read this entire thing to you, but basically we are the consulting arm of Network Rail. So at some point back in 2012, the powers that be at Network Rail decided that we were getting pretty good at this whole railroading thing, and maybe we should try to take some of this expertise around the world. So there was an international consulting arm created, and it's about 50% British, 50% foreigners, quote unquote, Americans and Canadians, who work for this organization now. So why did the UK move beyond simple train control? We know the story in the United States with Chatsworth. A red signal violation in the UK is called a SPAD. Just like many other things in England, there's a very kind of pithy, kind of cute title for it. It's called a SPAD. And SPAD is a bad thing. It's a signal passed at danger. And SPADs have been the cause of several major rail accidents in the UK. But interestingly, SPADs were not the principal reason why positive train control was brought to the fore in the UK or across Europe. There are a variety of train protection systems that have been in use in the UK, which are roughly analogous to automatic train control systems that we've had here in the United States. Automatic train stop type systems, transponder based, the train protection warning system that you see here, ATP, and then finally the stage that the UK is at, and most of Europe is at now, is rolling out the deployment of what's called the European Train Control System, ETCS. So here's the reason. Those two light blue lines are growth in passenger journeys and passenger miles. And you can see roughly around 1995, demand in the UK for rail service, just skyrocketed. But the one thing that you notice about that is the dark blue line is the length of our network stayed roughly the same. So we're carrying many more passengers on the same network. And so that's increased pressure to increase capacity. There's also a question of interoperability. Of course, with the coming of the European Union, the European Commission, there's been a push to kind of standardize things across Europe. It's not any surprise that interoperability is an issue across Europe, as there are a number of different train control systems. The Thales, which you see here, actually requires 7 completely separate train control systems on board the train because of all the territory that it crosses. So at some point the European Commission came forward and said we need to do something about this, similar to similar to the problem that we're creating for ourselves here in the United States with interoperability. The Europeans kind of looked at it and said we need to do something about this. So those were the reasons. So interestingly, the Chatsworth incident here, the red signal incident at Chatsworth resulted in those deaths with the head-on collision of a freight train and a commuter train, was kind of the impetus to push positive train control to the fore. It's the reason for the congressional mandate. In Europe, interestingly, it's interoperability and provision of capacity. The other thing is that Europe has been trying to develop, for some time now, the European Commission has been trying to develop this trans-European network so that there is seamless rail journeys across the entire continent, including, not only on the continent, but also in the UK and Ireland. And you can't really do that unless your trains can interoperate very well with train control systems and communication systems. So at this point, I hope I kept that really, really brief because I wanted to leave the meat of this for Tony so he can tell you a little bit about ERTMS, which is the kind of the European flavor of positive train control. And the thing I think you're going to get out of this, or I hope you get out of this, is that the same challenges that we face here in the United States and the same kind of growing pains we've had with positive train control here have been experienced in the UK in a very similar fashion. They're facing the same challenges, despite the fact that it's a single owner, operator, infrastructure owner, maintainer, as opposed to the United States where we have this kind of hodgepodge of Class 1 railroads, transit authorities, and passenger rail operations. It's been similarly challenging, and Tony's going to talk a little bit about the specifics of that system and then do a little bit of a case study of the deployment of ERTMS on the Cambrian lines in Wales. So, Tony?
Good afternoon, everybody. Am I the only token Brit in the room? It's been my experience since I've been over here, so thank you for having me in Texas. It's my first visit. So just to talk about our experiences with the European Train Control System, which is analogous to PTC. Basically, the way that that Europe went about having a trans-European network was to legislate, and today I've been listening a lot about the legal aspects and the funding aspects. But what the European Union did was they set a set of European interoperability directives, which are basically requirements specs, technical specifications, that mandated how different parts of the system would interact. And so rather than trying to prevent the system going forward, these regulations actually enabled it. And since the 1990s, since the 1990s, Network Rail, British Rail, Railtrack, we've been involved in developing the standards for interoperability. And actually we've rolled out a number of the systems in the UK, but also recently in Saudi Arabia and also in Australia. I was involved in actually helping implement the ETCS system in the Great Western Main Line in the UK, and also picking up the pieces when we delivered the system on the Cambrian line, which I'll talk to you about. So the European Traffic Management System, ERTMS, is made up of three components. The first component, which is analogous to PTC, is the European Train Control System, ETCS. And this is mandated by something called the Technical Spec for Interoperability for Control, Command and Signaling. When I started doing ETCS probably 15, 20 years ago, this was quite a complicated document. It had many paragraphs in it. When I read it again over the last couple of weeks, just to remind myself, a lot of the paragraphs were actually intentionally deleted. And this is because as we've evolved in our understanding of the system, there are things that we thought we had to specify that we no longer do. Intentionally deleted is a very elegant way of getting rid of some of those interfaces. The next element of the system is the GSMR, Global System for Mobile Communications for Railways. And again, there was a European directive called IRENE. We love our acronyms in Europe. European Integrated Railway Radio Enhanced Network. And this system is basically the secure transmission for all voice and data transmission. So all of the communications throughout Europe are now operating on GSMR. And finally, a system which probably has great advantages over here in the US is the European Train Management Layer, or traffic management as we call it. And basically this system is involved in the operations management, automated train planning, automated scheduling, recovery after a disruption, and also payload planning and load planning. And this is an excellent system because it allows one person to operate a network that covers a large portion of the UK. And similar systems are operating in Europe, where you have got centralized control centers where single or few operators can control the whole network. And if there is a major disruption, they can very quickly recover by pressing an auto recovery type button. Just a few slides on how the system evolves. So conventional wayside signalling, which you're probably all comfortable with. So you've got some colour lights, and the interlocking system controls via information sent to it from trackside. It tells the driver whether he can proceed with a green aspect or whether he has to stop at a red aspect. It's very basic, and this is how signalling is done in most parts of the world. Going on to the next level, there is a system called a balise, and the balise transmits information from the signalling system to the train. And basically this allows positive train control to be achieved with an onboard computer, but some very simple trackside equipment that is interfaced with the existing signalling system. So we have trialed ERTMS level 1 in some locations in the UK and found it to be a very good way of achieving positive train control. One of the downsides with ERTMS level 1 is it actually increases the cost of the system. Because you're adding in additional pieces of equipment, the Eurobalise and the interface equipment, we've seen an increase in costs of around 15%. Not major, but it does cost slightly more if you're going to go to level 1. Going on to level 2, this is where we start to take away signals. So ultimately, information can be transmitted to the driver's display unit in the cab of the train. So the driver doesn't look at colour light signals for his instructions. He has a driver's interface unit which allows him to see the speed of the train. And if you ever get the chance to operate an ETCS operated train, basically it's a bit like having a cruise control in reverse, and you push a lever and the system doesn't allow you to go over speed. And if the speed of the train should be reduced, you feel that the train is braking and you can't speed the train up. So it's a very good positive system. One of the benefits and one of the reasons why we implemented ETCS level 2 in the Cambrian line, which I'll talk to you about in a second, is that because you don't have line-side signals, that takes away a large portion of your signalling costs. So what we saw in our trial sites was that the cost of the systems achieved about a 70% saving in terms of capital expenditure and maintenance and operation costs against a standard colour light signalling system. And then going forward to ERTMS level 3, this is going on to the next step, and this takes away all restrictions in terms of capacity because you're no longer trying to fill block sections. So if anybody's familiar with the term moving block allows trains to maximize the usage of track so they can go as close to the train in front as the system safely allows them to do so. All of this is controlled via satellite communication, so that the positions of trains is done via GPS and via information sent from balises on the track. So track circuits, axle counters, methods of train detection are no longer part of the system. So this is where you can achieve a step change in both safety and also in performance. Equally, you can achieve about a further reduction in terms of cost. So for a level 3 system, we found that the cost of this would be around 15% of a standard signalling system. In terms of the functionality of ETCS compared to PTC, there's a list on the slide which basically lists the PTC main requirements. And ETCS basically complies with all of those requirements. So if you're looking for a comparative system or a system that you wanted to roll out in the US, ETCS would achieve all of the requirements of PTC. Obviously, you've got to get the safety approval, get FRA approval, but one of the elements that we have been discussing in California, would ETCS be a PTC equivalent system? And as part of the high-speed rail system, we are going to be making that case to the FRA. So the challenges that we had in rolling out ERTMS in the UK, and many of these will probably be familiar to anybody who's delivered a project over the years. Inertia in changing long-standard operating rules. So the European Union mandated how we would do things. We always know better in the UK, so we were always trying to change how the system was operating. And it was, we probably spent 30% of our time on the development and delivery of the project, arguing with Europe about how we thought things should be done. We lost every battle. Getting the signalling design industry and the supply industry to basically work together. After about 10 years, we came up with an idea where we set up an integration facility and got 4 signalling companies and 4 train manufacturing companies all to fit their equipment onto one piece of track, about 5 miles of track. And after a few teething problems, we managed to get all of the systems interoperating with every other system. And moving forward from that, we now know that if we buy any system, it will be interoperable with any other system that we buy. Probably the biggest challenge that we've had is the retrofitting of existing rolling stock. And with our first-in-class system in the Cambrian line, it took a year to fit the first train and took over £1 million. Unfortunately, it seemed to take almost the same for the second and third trains. But once we got into the swing of it, we managed to take the time down to about 12 weeks for retrofit. Most of the issues are related to the existing equipment on the trains, not the new equipment. The approval process, so we have similar approval issues as you have with the FRA, and it just takes time to get the case together, get all the paperwork together, get all the evidence together. And as I said, implementing first in class. And out of our control in the UK, but we were party to it, the European Union TSI specification was prone to change, and sometimes when we thought we were almost there, there would be a baseline change for the EU, and we'd have to go and retrofit our systems to be compliant with the new change. So just a few minutes on the Cambrian project. So we started this project back in 2003, and we decided to bite the bullet and go for a level 2 ERTMS system. It was one of the very first ERTMS level 2 systems in the world, so we had all of the teething problems associated with the first in class, not just in the UK, but in the world. So we set up a team of Network Rail, Arriva Trains, who were the train operating company, and Ansaldo, who are a signalling company. And we commissioned the first public use 4 years after the start of the project, and then the final commissioning of a second section of the line 6 months later. Unfortunately, to begin with, we had a number of teething problems. Performance was quite poor, punctuality was taking a hit. And we did have some, you could class them as category A, which is the most critical type of signalling being passed at danger in the early weeks. But this was largely due to operator training and making sure that people fully understood how they would react with the system. The line itself is very much a rural line, 218 kilometres, so about 160 miles, and runs through some beautiful scenery, mountains as we call them in the UK, but nothing more than a few thousand foot high. But the key challenge here was that it's very difficult to get to the locations for normal maintenance, normal operation, and if there's a fault. And one of the reasons that we went to ETCS for this particular line was that had we not found a cheap solution, we'd have shut the line. It wouldn't have become economically viable to keep it open. It's about 6 hours from London, and it's a very tortuous drive along country lanes. But actually, once we brought the line into use, two slides the same. I'll go for that second. So, sorry, in terms of fitting the train, there's quite a lot of systems that go onto the train. Each of the green boxes is a system that needed to be integrated. We need to find space, we need to find fixing points, we needed to put in wiring looms. So the reason that the trains took a year to fit was that there was a lot of equipment that we had to find space for, and a lot of equipment that we had to test. And this is one of the issues with PTC, retrofitting. If you can, my message is, if you can get a train that's factory fitted with a system, keep the factory fitted system, don't take it out. And we do hear that there are quite a number of standard European trains that are now fitted with level or a level of ERTMS, ETCS, and client railways are actually taking out the ETCS systems and then trying to fit something else. If you can get ETCS to work, stick with it. So the key lessons that we learned: making alterations to 20-year-old rolling stock is never a good thing. You've got to really understand the asset that you're trying to change, because it's the existing asset that causes you the problems, not your new system. When you're applying a new controlled braking system, an automated system will actually do it in a more controlled manner than a human. And you do tend to see some more rigorous performance being put into place. So if you're thinking that a new system will improve speed, improve performance, it doesn't. It does improve safety. Sometimes it can take a long time to get the first train of the day to start up, and that's particularly difficult if you've got a busy terminal station where you've got maybe 20 platforms and you're trying to start all the trains up together. You need to have a different approach to how you operate trains, and probably the toughest lesson, and the thing that took us the longest time to sort out with the whole of the rollout of the RTMS, was that the drivers continually complained about not being able to see their visual display system in front of them, which was a major concern because that's what they were controlling the trains to. We tried all sorts of things. We increased the brightness, we changed the colours, we put blinds up. And the thing that made the difference in the end was that the drivers' shirts that the operators wore were white. We changed their shirts to blue, the problem went away. So it's not always technology that gives you the problem. Making sure that your staff are trained and competent is you can never spend too much money on training and competency. And don't disband your team as soon as the job is commissioned. And I know we all do this, I'm always guilty of doing this, but on the Cambrian line I spent a lot of time trying to coax people back to finish off the job up to 5 years after they've done the final commissioning and gone off and done something else. So close out your list of problems and then move on. Don't leave problems open. Key message though is that the route is now fully operational, but as we've been talking about enhancement of routes, the pride in the local population, because they've got one of the most modern railway systems in Europe and in the world, is immense. This was a railway that was going to be closed down, but you go out and about on this railway any day of the week and people are using it. It's gone from a very tired, not used and sort of disabused railway to being the pride of Mid-Wales. And actually from an economic point of view, it's kept Mid-Wales going in terms of an area. Otherwise, if it had lost the railway, it would have become a very deprived area. So doing the work that we did on the RTMS has really improved the Mid-Wales area. Okay, thank you for your time. I hope that's been of some use.